everybody, and welcome to our Open Science Skills panel, where today we're going to get to know a few of the individuals who help make our Open Science Skills training possible and give you a couple of behind-the-scenes look at what goes on here at Don't Use This Code when we are preparing and delivering an Open Science Skills training. Additionally, since we are going to be asking a few of our teaching assistants some questions, I want you joining us there from the audience to also be able to ask questions and participate with us in the chat. And so that means that if you have a question that you want us to answer or address, if you're curious about any details, please go ahead and use the Q&A widget for that feature. And if you simply want to chat, say hello. I see that we are already saying hello in the chat, and that makes me so incredibly happy. Please go ahead and use the Zoom chat just for that. But before I introduce our guests who are going to be joining us on video for today, I wanted to share with you all that there is one more individual who won't be joining us on camera who makes all of our trainings and events like this one very possible, and that is Dr. Courtney Hahn. Dr. Hahn is in the background of absolutely everything that we do, and I know that you all have gotten to know her through your various communications, and so I would greatly appreciate it if you could join me in appreciating the work and effort that Dr. Hahn has put into the open science trainings here at Don't Use This Code. With that all being said, let's jump into today's star guests. We are joined by two of our regular teaching assistants who have taught segments, answered questions in the Q&A, or chatted with you all here on Zoom as part of our open science trainings. And so first up, I would love to introduce Sammy Chatham. Sammy is pursuing a PhD in kinesiology at the University of Alabama with a bachelor's in psychology, like myself, and a master's in kinesiology, unlike myself, from UA. She is passionate about advancing her research in the doctoral program while implementing and advocating for open science practices. And so, Sammy, I'll give you a moment to introduce yourself in just a couple of minutes, because I would also like to introduce Dr. Kelsi West, who will also be joining us. Dr. West is a bioinformatics expert with a PhD in genetics and a background in epidemiology, specializing in back-end systems that support genetic research and innovation. With publications in journals like Cell Reports and a commitment to open science, she bridges life sciences and software engineering to advance transparent and impactful discovery. Now, Sammy, Kelsi, what we have here today is a series of questions, and I want to know first, are you both ready? So Sammy, are you ready to answer some questions and share a little bit about yourself in open science?
I'm ready to go.
Fantastic. And Kelsi, how about you? Are you also ready to answer questions, share a little bit about yourself as well as open science?
I'm ready. I'm excited for this.
Excellent. Then let us jump right into what we have prepared for you all. Now, I mentioned a series of questions, and what I will do is I'll go ahead and share the very first question on my screen. I'm going to read each of these questions out loud, and I'll prompt either or both of you to answer each of these questions, where we'll spark some meaningful discussion. So let's go ahead and get started with the very first question. So you'll see my screen. Behind me, you'll see my screen. I'll hide over here in the corner. And our very first question is, what is your current role? And if open science were a movie, what genre would it be? So this is a two-parter question here. Let's start with Sammy. So what is your current role? And if open science were a movie, what genre would it be?
I love this question. The first thing that comes to mind is it definitely does not need to be science fiction. So if it were to be a genre, I think it would be a documentary. And honestly, kind of thinking about like my role as a TA or mine and Kelsi's roles as TAs, I think that we would kind of be the narrators in that documentary, kind of sharing the message of open science while also offering more of a behind the scenes look through our trainings about how to practice open science in our own research. And it's a really fun vantage point to have because we're kind of getting the best of both worlds, getting to simultaneously kind of share the importance of open science with our colleagues around the world like today, while also learning how to best implement it within our own research.
That is very well said, and I really appreciate the documentary perspective. Let's go ahead and also hear from Kelsi. Kelsi, same question to you. What is your current role? And if open science were a movie, what genre would it be?
My current role is a data science manager for a cancer research organization and dealing with a lot with clinical data and human data, genomic data all the time on a daily basis. And if open science were a movie, I'm going to go a little bit different route. I think it's a romantic drama slash comedy where you have these options that you can choose from. You know, you always see the person in the main role trying to decide who they are in love with or who they want to choose. And they have to go through all these trials and find a lot of flops along the way. And ultimately, you can see it's obvious you want them to choose, in our case, open science. But sometimes they have to deal with a lot of things before they end up choosing that. And I think ultimately, in the end, you end up choosing open science or choosing the best person for your romantic drama story. But that's where I thought of when I thought of the genre of movie for open science.
Excellent. And I love the anecdote relating those things. Now, I'll also go ahead and answer this question. My current role, I am a trainer slash instructor slash consultant here at Don't Use This Code. And I had an academic, we'll say an academic experience in what feels like a past life at this point. So of course, you'll also see me instructing many of our open science skills sessions. And my thoughts on if open science were a movie, what genre would it be? Well, I would say that open science would be a mystery movie. And that's because you keep uncovering these new ideas or maybe these new tools, and you're thinking, wait a minute, I thought this was already solved. I thought we were already done with this. And of course, you find this new mystery and you pull on the thread, and then you find maybe a new tool or a new perspective or a new way of doing things. So it is a mystery movie, but there is no end to this mystery, or it feels like there's no end because the mystery just keeps unraveling and going on and on. But now that you all have gotten a chance to know, the three of us, what we do, and of course our movie genre we would assign to open science, let's get into some more personal questions here. So our very next question, and for this I'll start with Kelsi and then go to Sammy and then myself. What was your aha moment that made you think, yes, open science is exactly for me? So Kelsi, what in your rom-com genre would you relate to here for your open science aha experience?
I would say, if we're still relating to the rom-com, the disillusion of when I did start my graduate work and I got into science to share and collaborate. I believe everyone should be building on the research that you use to help their own research, and as a whole community we should be building off each other's work. And so it was really when I got into graduate work and academia, the hidden nature of it all and wanting to make sure everything's really protected and keeping it close and never getting scooped. It really was a disalignment. It didn't align with what I got into science for and what I got into research for. So from that point on, and slowly realizing that over time and the systems that are ingrained in those processes, I knew open science is something I'm going to push for in my career and encourage others to do as well. Whether it's little steps or big steps, but I knew that from this point on and definitely pushing against different boundaries, I wanted to push for the open science and reproducibility and translational research as a whole.
So it feels like it was that realization where you're thinking, this is what science should have been or should be all along. We should have these transparent methodologies, and we should make sure that our work is reproducible and it wasn't just kind of this one-time thing.
Absolutely. I feel like I
Now,
always felt
Kelsey,
like
you
that.
used a term in there that I'll ask you to go ahead and define. Yeah, I'll ask you to go ahead and define for our audience, and that is the term scooped. Can you go ahead and share with us a little bit about what scooped is?
Yes, scooped is when you discover something and you don't want anyone else to discover it before you get it published or put out there for the world to know that you found it. So really the aspect of you can claim it, it's your research, but before anyone else can do that same thing. So that was always a concept that we were dealing with in our research. or a lot of people deal with.
Absolutely. And Sammy, I want to pull you into the conversation here as well, because have you also experienced it? Because since you both work in very different fields, have you also felt this pressure of, oh, if I'm too open or too transparent, I might get scooped?
Yes, it's definitely kind of been, kind of in the back of your mind. You're thinking like, oh, especially kind of at this point, having just finished the first year of my PhD, and you're thinking about dissertation topics, and everyone's really interested in, what you're studying, and it's like, how specific do I get? But at the same time, like, I found that sharing isn't, the worst thing in the world. And honestly, you start to find out that people actually want to collaborate and they get really interested and they're like, oh, if you're going down this road with your research, maybe try these few things that I've done in my work. And I think that's where, while that is a very real thing that a lot of people deal with, the scooping, I've found, and I may have just been fortunate, a lot of people want to collaborate more so than kind of steal those ideas, if that makes sense.
Absolutely. And I think there's kind of like a survivor bias here that's involved of for every one nightmare experience where you do have somebody you thought you were collaborating with stop responding to your emails and just kind of steal their work and publish it by themselves. You have at least 20 other stories of successful collaborations where I was emailing a person, we worked together on an experiment, we published the results together, and no, we never fought or bickered about, who's first author, second, so on and so forth. So I really appreciate that. Now, Sammy, let's move on to the same question for you. What was your aha moment that made you think, yes, open science is for me?
So, the first time I ever heard the term open science was actually just last year. So I did one of the open science trainings with Don't Use This Code, and you, Cameron, actually brought up the idea of, have you ever been looking for an article and ended up getting blocked by a paywall? And I was like, oh, yes. Like, at that point, I was a master's student about to defend my thesis, and that was my first time doing a lit review. So I was very familiar with that frustration. And then kind of throughout the training, talking about how open science is really meant to make, data and research more accessible to everybody. I was like, this is something I really want to get on board with, especially kind of early on in my research career. Because I really loved the idea of being able to have access to, all the research that I would need to do my own research and to help other people do theirs as well.
Excellent. So it's kind of relating to a piece, something that seemed very anecdotal, but it was it's a powerful motivator to say, yeah, this is really frustrating. And also, why can't I access these articles for free? I've had this very same experiences, especially transitioning for when I was in graduate school. I was at the UC system, so massive University of California system. They have relationships with a lot of very large publishers, and just accessing any article, I was very surprised when I couldn't access an article through my library. But that said, when I left grad school, just realizing how much knowledge I no longer had access to read was very, very unnerving. And so, although I don't read as many articles as I used to, it's still, I think it's crazy at one, how much those articles actually cost to access. I'm not paying $20 to access a PDF, but two, just the sheer volume of articles that are behind a paywall in the first place. So I very much agree with you. And that was a part of my aha moment, but my personal aha moment was the first time that I was actually able to reproduce somebody else's work from a link that they had provided to me. Because I feel like so often you will get those links of like, oh, you can find so and so here. It's on this GitHub repository or something like that. And you go, it's either a 404 or you see the data files, but you have no idea what you're looking at or what to do with it because they'll just dump some original data on there and they'll dump maybe a script, but then they forget to tell you that there's like 5 other things that you need in order for the script to work or to run. There's no README. So it was the very first time where I was able to just download a zip folder and then open it up and see that there were a couple of instructions. They weren't fantastic instructions. It was just kind of run this command, run that command, run that command, and you should have the same numbers that I got. And it actually worked. And so that was the first time I'm like, wow, like why can't I do this with every single article that I come across or every single data set, barring, some things like volume limitations and things like that, some edge cases. But I feel like the bulk of our knowledge should be able to be that easily reproduced, especially when there is computational work involved where you can automate it or script it in some fashion. It should be that easy. And so that was my personal first aha moment when I was thinking, it's just kind of this relationship of why aren't we all doing this all the time already? And then it was that step into, oh, this is open science. That's what this is. And so that was my first kind of aha moment where I was thinking, yes, this should be the status quo. And that's what we're pushing for here today. All right, let's go ahead and jump into our very next question. And that is, in one sentence or less, and if you give me 2 sentences or 3, I don't think we'll deduct any points from you. Just for today, we'll have that be a special rule. How would you describe open science to a curious friend or classmate? And I'd like to hear from Sammy first and then Kelsi. So Sammy, how would you describe open science to a curious friend or a classmate?
I think I would say that open science allows everyone to have access to research and data from university researchers all the way to citizen scientists. So basically, open access for all would be my little one sentence summary there.
Absolutely. And Kelsi, first, before you share yours, Kelsi, do you agree with Sammy's sentence there?
Absolutely. Absolutely. Open access is what we're looking for everyone. My one sentence or less would be the building blocks so that everyone can reuse research and reproduce research. But basically how it's the building blocks for everyone that will be continuing in the science community with your work and everyone's work.
I like that. Not even just a single sentence, but just a single term there, building
Yeah,
blocks. I
building
love it
blocks.
because we think of just knowledge kind of being the building blocks for future knowledge. But nowadays it extends even further than that, where it's tools serve as the building blocks for other tools, or tools even can serve as the building blocks for knowledge because it enables analyses that you never thought possible. And it makes me think back, and I know in bioinformatics, you all have been doing this for decades of like, whoa, we can do this now. That's absolutely crazy. But in my own work or my own experience, the advent of the MRI was this crazy way that we could look at the human brain in a very non-invasive format. And we got higher both temporal and spatial resolution than any other technology that we had used before. And so it's just crazy how this piece of technology that was designed for medical applications then became a building block for a whole corner of literature that has gone, I think, the last 25 years or so with just brand new insights about how the human brain works, how one region's connected to another, and what actually is going on when we're thinking about things, when we're conversing, when we're tasting things, so on and so forth. So I love building blocks.
And imagine if they hadn't made those instructions clear enough for anyone to use the MRI, right? It would have been a building block for all that other research. That's amazing. I was getting
Absolutely.
secondary stress from your story before about going onto the repos and trying to reproduce someone's code. Yeah, that's if it's not clear enough, no one can build off of it as well.
Absolutely. And I think it ties in, I'm going to relate it to your protocols.io segment that you've
Sure.
taught, because it's kind of the same idea of like you need these very fine detailed descriptions about what was done, how, when, and in what relation to one another. So I love building blocks. I don't think I can beat building blocks.
I'm sure you can. I'm sure you can.
Well, I'm going to suspend the one sentence rule because I do have another kind of anecdote. Because when I think of open science to a curious friend or a classmate, I went into this world where the person I'm talking to might not have a research background or might not have a scientific background. So I was thinking, have you ever been in, we'll say grade school and taken a math quiz or a math exam, a math test, and you got some points for getting the answer right, but you got more points for showing your work and getting the answer right? And I think that's what open science is. We need to start attributing kind of more points, not just for does the answer look good and sound good, but have you also shown your work of how you would get there? And in an impossible world, it would also include the fact that, did you just kind of memorize and use the formula to get to the answer? You're just showing me what I wanted to see? Or did you actually include and not erase anything and say, oh, well, I tried this first and that answer didn't feel right. So I thought something was wrong with my analysis. So then I tried this second and this third. And that's when I finally got an answer that looked looked in line with what I was expecting. Therefore, maybe providing not a necessarily true confirmation that my result is accurate, but at least a little bit of more confirmation. And you can also see the other two attempts that I made here. So not a sentence, but I thought it's a very important way of just kind of showcasing that open science isn't about the result. It's about the process that leads to the result. And in this vein, science is really about the process. It's not necessarily about the result, in my opinion. But with that said, let's jump into our very next question. And this should be a fun one. If you could bust one myth about open science, what would it be? And so let's start with Kelsi on this one, then we'll go to Sammy. But Kelsi, one myth about open science, what would it be?
This is a hard one. My initial thought goes to that you wouldn't get credit for your work. I think that's what most people are worried about, and a lot of academics especially. But that's absolutely not true. And there are tools and systems out there to make sure you get credit and even get more credit, in my opinion, for each individual contribution that you have.
So would you say that this could, when you say you don't get credit or you won't get credit, could this kind of stem also into if you're practicing open science, you are at a much higher chance of getting scooped than had you kind of worked in a dark cave for 2 years and then said, here are my results?
Absolutely. I mean, I think that fully relates to one another. And if I lost my train of thought, but if we don't actually cite our work and consistently share with others for them to cite our work, and maybe your lab mate or a lab across the hall found something and you want to be able to cite that. It could be a small contribution, but they're already getting credit for the contribution that they've had with your work instead of isolating themselves in a cave, like you say, to where no one knows anything about their work. It's very kept close to them and that's it. Then they're not been able to be cited or credited as they should be for all the contributions that they could potentially have.
Mm-hmm. Absolutely. Now I'm curious, Sammy, same question to you. What is your one myth about open science?
So this is a conversation I've actually had with a lot of people when I talk about open science because they'll say, I'd love to participate in open science, but it's just so expensive. And I'm like, no, no, no. Like to participate in open science, it doesn't mean that you have to pay the couple $1,000s potentially to publish your article in an open access journal. There's lots of ways to participate in open science. And even in terms of like the open access, you can self-archive articles and you can upload data to a data repository. There's lots of ways that are very cost efficient or even, free to practice open science. That would probably be the biggest myth is that doing open science doesn't necessarily mean that science is more expensive now.
I love that. I absolutely love that. Now, would you also venture to say that doing open science now also does not necessitate that you are going to have to do all of open science? Or do you think I can just start with maybe just doing one aspect, maybe just upload my data to Zenodo or something for free, and then just have that be my first dabble into open science?
Absolutely. And I think what's so cool about open science kind of as like a whole process is like even with me, for example, like I didn't learn about open science until after I worked on my and finished my master's thesis. So even in like looking at publishing, it's like, what can I do, if I don't want to pay the fee? So looking into like self-archiving, things like that. So you can kind of jump in at any point in the process of open science, which I think is really cool. So yeah, so I would definitely say, you can dip your toe in, kind of do one little part of it and kind of build from there and build up your skills in open science.
Yeah, I love that. And I think it makes it much more approachable because, I mean, we do our about 6 hours of training on open science and we're only scratching the surface. And I tell everyone that we are only scratching the surface. There's so much more to know and to learn and to understand here. But that doesn't mean that you need to have a PhD in open science on top of your PhD or master's or whatever you have in the field of your interest. And so learn what you can at the time that you can and apply it when you're able to. So I absolutely love that, Sammy. Now I'll share my one myth, and I was on the fence about sharing this or not because it uses a term that I absolutely hate, and I know that many other people don't like. But I will say this: when we talk about open science, we often talk about the reproducibility crisis and how this is facing many, many fields. However, there is a very common myth, as somebody who studies psychology, that only the quote soft sciences are undergoing a reproducibility crisis because they are wishy-washy, so to speak. They're not really doing these rigorous statistical applications, or they can't actually measure the thing that they think they're measuring. Of course, people will lie on a self-report. Therefore, only soft sciences will have a reproducibility crisis. And I will say, after seeing thousands of attendees join us for these open science skills training, I always ask, what field do you study, and do you think that it is currently undergoing or has undergone a reproducibility crisis? I have seen responses from every corner. Disciplines I didn't even know existed, but many of them traditional fields that which you would deem to be a hard science. So it was a very nice, just here's some evidence in your face to say, no, this is not just a soft science thing. You're not the only people or group that cares about doing open science. And in fact, all of these other fields, all of these other disciplines are also undergoing what we would call or consider to be a reproducibility crisis. So that is the one myth that I would pop or burst about open science, is that everyone will have a reproducibility crisis at some point. The only way that you can verify that you are not undergoing a reproducibility crisis is by actually being able to reproduce the work that has been done, which usually means that you need all of your research artifacts in some accessible location for others to use and reuse. So that would be my one myth to bust there. I'm curious though, in the chat, if you could also let us know what myths you think need to be done away with about open science, because I know that the three of us are not the only one with opinions or thoughts on this type of question. I think this is a very fun one as well. In the meantime, while our audience is entering their thoughts into the chat, let's jump into our next question, and that is, what is one cool thing that you have seen open science make possible, either big or small? And I'd like to start with Sammy on this one, and then we'll go to Kelsi. But Sammy, what is the one cool thing that you've seen open science make possible?
Something really cool that I've seen kind of come out of open science is, honestly, this is kind of a broad answer to this question, but just like the collaboration that's possible through open science, that I can be working on a project here and somebody can comment on it from around the world. And I just think that's a really cool facet of it, to be able to kind of get that input and ensure that, I'm doing good work and you kind of have more eyes on it, which is, I guess, and at first can seem a little bit scary, but it almost makes me feel better because it makes you more confident in the work that you're putting out and in the research that you're putting out, in an attempt to get kind of closer to the truth, which is why we're doing research, to try to figure the world out a little bit. So that's kind of my broad answer to that question.
Amazing. I also agree with you. I'll talk about a slightly different aspect of the community when I go, but it's so amazing how many people have gotten together to say that, yes, I don't care what field you work in, but this is an important idea. This is an important way to apply it or way to go about it. So thank you so much for sharing that, Sammy. Now, Kelsi, you'll be up next here. What's one cool thing that you have seen open science make possible, whether it's big or small?
I think, and it might contribute to your idea, but I think that each one of the tools that are well documented through, and when I say tools, I'm referring to code or software solutions that have been implemented. And for my particular field, analysis of RNA or DNA, and the way individuals can then contribute back to those tools to make them even better. So with open science, when they do share the code for these tools and the repos are available on GitHub or something, and people can constantly contribute to making that tool better or identifying issues, solving their own issues, that they might find with the tool and contributing back to that tool is the best, in my opinion, when that happens. And a well-maintained GitHub repo is the best thing. I love to see frequent dates and comments and things like that. So I think just, again, going back to the building blocks and how we can keep contributing, kind of with Sammy's idea too, of the field just constantly can grow together when it's shared clearly and openly.
So it sounds like not just tools, but kind of that positive feedback loop that's then created of the longevity and the support of those tools.
Absolutely. And just, yeah, the ability to, and the tools. So GitHub being a cool tool as well, an open science, but having that being individuals can contribute back to different software solutions or different code that is promoted or published there. So always just constant like building and yeah, positive feedback and growth of the tools themselves and leading to cooler analyses and discoveries.
I absolutely love that. I do have a follow-up question for you on that topic, though,
Sure.
because the creation of these open source tools also then causes at least one person to, for maybe a short time, maybe a long time, be the owner of said
Yes.
tool. And so I'm curious, what are your thoughts on how do we balance that? If I research field something X and I make a tool that helps other people research X, but then now we have this whole community saying, hey, can you add this? Can you add that?
Mhm.
So on and so
Mhm.
forth.
And
Is it
typically
okay
it's
for me
done,
to,
during your PhD or
yeah.
some kind of work you're doing, and then you move on to a different role or position that you don't have time to maintain those.
Mhm.
Absolutely. I think with that, it's still feeding into to how we can help with that issue is feeding into the open science of collaboration. So if you're working on a tool and you implement it, bring some lab mates along with you or share it with other collaborators to where they can also help you facilitate and implement that tool. You're still getting credit as the main, sole author or sole contributor, but individuals are also in the community able to contribute to your work and help grow that tool and keep it sustainable. You don't want to I have seen a lot of those. I'm sure you have too, where individuals publish a certain tool or code on GitHub and then they never look at it again.
Mhm.
Um, but and it takes honestly, an individual that could be not related at all to then take that on as the second, work in progress for that particular code set. So I definitely think bringing people early on as collaborators and getting that community built up for that even if it's a sole tool on GitHub. Absolutely.
Yeah. I love that. And I think it is one of the more pressing issues that we see because we've had this huge explosion of just the number of tools available. Not only do you have to wade through and figure out the ones that are actually useful to you, but now you have to think, is this going to be maintained in the future? Is there a large team working behind it? Is it just one individual? And so on. And then go through, of course, all those GitHub stats that we talk about in class as well.
Absolutely.
Awesome thoughts there, Kelsi. Now, my one thing is actually, I think it lands somewhere between what both Kelsi and Sammy said. But in preparation for some of these courses that we've put together, I, of course, do my own research. And as part of that research, a lot of the times research is just code word for I Googled a couple of things, or many things in this case. But one of the things that I ended up coming across was a small GitHub repository. And this GitHub repository, it had kind of the bare bones. It had a README, it had like a script or two, and then I think there was even just one small data file in there. And in the README, it said that it was the code to reproduce X for whatever publication that they had. And you'll see repositories like this if you look hard enough. They're not too hard to find. But the cool thing that I loved about it was that there was a closed issue on this GitHub thread and an open pull request. And so here, what had happened was somebody, at least to my knowledge, completely unrelated to the individual who created the GitHub repository, also had come across this code and said, hey, I think I found an error or a bug in your logic. and then even went so far as creating a pull request to fix that. And in the thread in the issue that ended up getting closed was a nice back and forth between the original owner, the original maintainer of the code, as well as this new individual. And so it was just really cool because we're talking about community. Sammy mentioned community kind of at the macro scale. This is the micro scale of just because you put your work out there in public, you're going to get feedback from people who you would never encounter otherwise, because it is a great place for other people to search or to stumble across your work and also engage with you. Something that's kind of the traditional publication interface does not give you, because you'll go read an article by an author and then you'll cite them, and that person likely will never end up knowing, who cited them and why, unless you're constantly searching yourself up on Google Scholar, like I may or may not do. So that being said, I think we've landed kind of somewhere in the middle between these two that I think is really cool, is this kind of micro community that will pop up just because you put yourself out there. And so that's what I love about open science. All right, let's jump into our very next question. And this is going to be specifically about our DUTC, or our Don't Use This Code, open science training sessions. But what has been your favorite moment supporting these open science training sessions? We'll start with Kelsi and then we'll go to Sammy. So Kelsi, your favorite moment.
My favorite moment, there's so many. I really love our team and all of our TAs like Sammy, and working with you, Cameron. You're a great instructor, and Dr. Courtney Hahn in Brooklyn, and everyone at Don't Use This Code is really great. But really with that, going on the community theme, just the interaction we get in the chat every time I'm assisting with a session. Everyone's ideas are so interesting, and it's very clear that everyone else is dealing with the same, like you mentioned, the reproducibility crisis, the collaboration aspects, the different fields that they're in, and everyone's just so active and friendly. And I just love meeting new people through the chat, and everyone who's really passionate about open science like we are.
Mm-hmm. I absolutely agree. I think the community that we've built here is something very special, and just seeing all these people excited about this stuff gets you also very excited as well.
Yes.
Excellent. Thanks so much, Kelsi. And Sammy, what about you? What's been your favorite moment supporting the DUTC Open Science Training?
Honestly, I'd have to say it's pretty much in line with Kelsey's, and being a part of these trainings and kind of seeing the growth and excitement surrounding open science throughout all the people that have come to the open cohorts or the closed cohorts, and being able to, even follow up with them afterwards, connect on LinkedIn, and kind of see how they're utilizing open science and the open science principles in their own research has been really rewarding and really exciting to see. So yeah, definitely the community aspect, and getting to kind of learn and grow from each other has been really, really fun.
Yeah, and I think this is one thing, Sam, that you did that Kelsi didn't do or hasn't yet done, is you actually would sit down with attendees from our courses in a one-on-one session, and this was often under the scope of like a makeup or a discussion, an open science kind of discussion with them, and so you did get an opportunity to just capture this kind of one-on-one feedback, this one-on-one of like, what did you learn, what's important to you, and so. It sounds like that's been a pretty pivotal experience for you, just getting that opportunity.
Yeah, it's honestly been so cool. And those one-on-one sessions, getting to, literally meet with people from across the world and talk to them about their research and how they're implementing these things was just kind of mind-blowing. And it's an opportunity that I don't think I would have had otherwise. So I'm really, really thankful for that. And it was, yeah, definitely a really rewarding and cool experience.
Absolutely. I wholeheartedly agree with you. Now, my favorite moment is kind of similar as well. It's if I had to pinpoint it down to a particular moment, I couldn't just pick one. I have to go with two. So my first kind of favorite moment was it was during a class. We had like 180 attendees on the call. And I'm saying this number because I know most of the attendees, I don't believe, know how many other people are also there. But we had a very large volume on the call. And on top of that, the chat was incredibly active. They were talking about all of the topics that we were covering, discussing open science. And so just like you, Sammy, it was just amazing just to see all these people across the world be so passionate about this one particular topic and share that passion with people whom they had never met, share that passion with strangers from the internet, so to speak, but to also then see that passion returned with, oh, you do X, Y, and Z. Well, I also do X, Y, and Z. Here's like a tool that I absolutely love using and I could not go a day without using. So it's kind of again that community aspect, but just seeing it happen and unfold before your very eyes is always very neat. Now, the second favorite moment for the open science training stuff, it was the very first, and I will say this happens every time, but in our more recent classes that will do, we'll actually have one of our TAs perform a teaching segment instead of in addition to engage in the chat and all the other things that you have known to love them for. And so Kelsi, was actually seeing you do your very first teaching segment because that was the first time that we had done this, and it was so amazing because it was on a tool I had never heard of and I have never talked about because this was just something that was brand new to me. And I know I lead every segment with, I know some things about open science, but I know there's going to be a lot of us on the call who may even know more than me, or you might know more within your respective field than myself. But it's such a great time for us to share a new perspective and a new tool and how that can help everyone, regardless of their field that they're in. So Kelsi, that one will go to you since you were
You are
you
so
were the
kind.
first one. So it's the de facto favorite moment there. So I couldn't whittle it down to just one.
I loved doing that. I loved that the team felt confident enough in me to present that information, but I loved, yeah, having that opportunity to present as well.
Excellent. Well, we love having you, Kelsi, and I'm sure we'll be doing more of it in the future. But with that said, let's jump into something specific about tools. And I'm curious, what is one skill or tool that you did not expect to use, but you now absolutely love? And we'll start with Sammy here, and then we'll go to Kelsi. So Sammy, what's one skill or maybe just one tool that you didn't expect to use, but you now love?
I would have to say, honestly, I guess this would be considered like one of the tools, like the ORCID IDs, being kind of like newer to publishing and things like that. I didn't really know the importance behind it kind of until we talked about it in one of our trainings. And so I got one and I've started utilizing it, and I really like it, and knowing that kind of all my work going forward will kind of all be tied back to me, kind of in that same thing, like applying credit. And so, yeah, that's a tool that I've really come to enjoy, even like early on here in my scientific journey. So, yeah, that's one.
Awesome. And then Kelsi, what about you? One tool or skill that you didn't expect to use, but you now love?
I would say the tool that I now use is Zenodo. Unlike protocols.io, I wasn't familiar with Zenodo as much as I probably should have been in my career, but I use that now for, different aspects that I need just a citation for, or to get, the credit or the citation usage that I would need for a particular code, or, GitHub repo or publication. It's not just tied to something that I have to publish in an article somewhere in a journal. And I really love Zenodo. Is a great tool for that.
Absolutely. I agree with you on Zenodo, and I also love using it for kind of like versioning data sets since you can use their version DOIs.
Okay. I
But
didn't know that either. So
oh, there you go. They
yeah.
have they're like it's like a concept DOI, and so what you
Okay.
can do is you can have your DOI have different versions effectively, and they'll give you the kind of like the link to each version, so you can hard link back to a particular version of say your data set. But then they'll also give you another link. This is the concept DOI link, and that will always take you to the quote most recent version as well.
Oh, good. Okay. That's
Yeah.
awesome.
And so
Awesome.
I like using Zenodo to like store the data, and then of course GitHub to store the code. And then in GitHub, I'll link back to the specific version that I used for the analysis at that time. And that way I don't have to like copy my whole data set and then throw it up on GitHub and then
Absolutely.
encounter those GitHub large file system issues and things like that.
That's awesome. Good to know.
Yeah. One tool that I love, and I actually haven't talked about this during our open science skills training. I've talked about this during a couple of other trainings as since it's a little bit more heavy on the software side. but it is a tool called Pixie, and it is for programmatic reproducible environments. And the tool that I would compare it for anyone who's familiar, it's going to be something like Docker or something like Podman, which end up having a very large technical overhead. You need to know a little bit more about how to install this thing, about how to set it up and how to get it running. This tool Pixie has a very low overhead to get set up and get running, which I think is incredibly important when we're talking about open science, because you cannot assume or presume that somebody has a very in-depth kind of software background, even though you want them to have as in-depth of a software background as you do. You have to face the facts. Not everyone's going to. And so this tool provides a nice way for you to have a reproducible computational environment with things like with features like having lock files, meaning that they're going to get the exact same copies of all of the packages, all of the programming languages, and everything that you're installing in this environment. And so if you haven't checked out Pixie, go ahead, check it out. I'll drop a link in the chat as well. And I promise that Pixie does not pay me to say things like this. I genuinely just enjoy using it. I think it's a good improvement on its theoretical predecessor, who I'll leave unnamed. And it's really a great tool for sharing computational environments across computers. All right, let's jump into our next question though. And this gets more into how we as instructors, or we as kind of mentor, on stage figures, present ourselves. How do you help people feel welcome and excited about open science, especially if they are brand new to it? Now I'll start with Kelsi for this one, and then we'll go to Sammy. But Kelsi, how do you help people feel welcome and excited about open science?
I think all of us here at Don't Use This Code are super friendly, and I try to encourage that through, initiating with the chat and the different participants that we have. But also, when people come to open science or even ask me about open science, I try to encourage them with the idea that we were talking about earlier of you don't have to do big things to start open science or even to help with open science. You can do little steps along the way, and that can contribute to really big efforts overall in the field. So just little by little, you don't have to feel overwhelmed with everything that you've done wrong in the past or done, the different tools that you're using that are incorrect or something, but just little steps make the biggest difference over time. So don't be overwhelmed, and just encouraged to take little steps.
Excellent. A gorgeous reassurance from Kelsi. And I think that's so important, because it's just in the general sense of doing research. I don't know about you, Kelsi, but like when I was doing research, I always felt like I was doing things wrong.
Absolutely.
And so just having that reassurance.
Speaking from experience, yes.
Yeah.
I would love to go back and do things differently, but now going forward and knowing what I know now, the little things that I can do to help open science and the community as a whole, I will do.
Absolutely. And it's important that you pass those things down, pass that knowledge down, so that we avoid, and it comes back to these building blocks, right?
Right. Absolutely.
Excellent. Sammy, what about you? How do you help people feel welcome and excited about open science, especially if they're brand new? And so just in case we lost Sammy there, I will share mine about feeling welcome and excited. The two things that I always try to make sure that I bring to the table as an instructor are going to be energy and communication. Now, energy meaning when somebody joins a community that is new, they likely won't know anyone unless they were invited by a particular individual. This leaves kind of two very likely scenarios and a third less likely scenario. One, if you're in a new community and you don't know anyone, you tend to keep to yourself. If you're in a community and you know a couple of people, you tend to just hover around those same couple of people and whoever they tend to hover around as well. And so this starts creating silos or cliques within your community. And I think as somebody who provides instruction, it's easy to say, wow, look at all these people that I can bring together, but also kind of ignore or look over the fact because you're sitting too high level and just observing and saying, okay, well, there's a lot of silos in here, but that is okay. And so I think from an instructional perspective, it just takes a little bit of energy on your behalf because I'm a big proponent of you only get out whatever you put into something. And so if I'm up here, up on stage, exuding a lot of energy as much as possible, then it is more likely that other people are going to mimic that same kind of energy or feel that they have that same type of energy as well. And so I find that sometimes it just takes a friendly nudge or maybe relating to something that somebody said to spark a little bit of more interest in not just the small silo that you have within that community, but to start expand and grow within that community. And I think that's how you build a very strong community. So my answer to this question would just simply be put as much energy as you can into everything that you are doing or into anything that you are doing, and also make sure that you have great communication skills as well. And that will help people feel more welcome. But Sammy, I see that you are now back with us. Sammy, what about you? How do you help people feel welcome and excited for open science?
Yes, so I honestly really loved what you were saying, Kelsey. Like kind of thinking about open science as a very like forgiving and kind of grace-filled process. Like we kind of do the best we can until we know better. So I really, really loved that. And yeah, I think kind of emphasizing ideas like that in the trainings and kind of just opening up the discussion, answering the questions that people have, because oftentimes I find they were the same questions that I had at first. So yeah, and just kind of being welcoming around that, engaging in the chat, yeah, and just connecting with as many people as possible and having those conversations whenever available.
Excellent. Thank you so much, Sammy. I love your thoughts on this and sharing that. Let's jump into, I think, what will be maybe our second to last question, maybe our last question, we'll find out. But I'm very excited for this one because, again, it goes into a little bit more of how do you market or how do you make these virtual trainings feel personal and meaningful? And now I know earlier I just shared that for some of these classes, we have over 100 people on the call. And so it's not going to be actually possible for us to make it feel like an individualized or very personal or meaningful session. But there are things that we do that I hope everyone in the audience at least appreciates. And so, Kelsi, I'm curious, what is your go-to strategy for making these global virtual trainings feel personal and meaningful?
I think that the interaction and asking for, participant feedback on our discussions or our chats, I think you do a really good job of engaging individuals that way. So even though our team might not be individually contacting a person, someone else from the community or who's on the training is interacting with those individuals and might trigger a response from someone who might not have wanted to engage as well. So I think that is a really good strategy. And again, making sure that you're always friendly and engaging. And I agreed with your energy statement. I think whatever energy you bring to an event or a particular test or skill or anything that's going to be matched for you with other participants or and people and being engaged. So always bringing the energy, always bringing the kindness and respect that everyone expects from anyone participating in an event, because we want people to enjoy open science. So how would we expect that if we're not acting in a respectful or kind, engaging way? So yeah, I think that's some of the strategies I think are great that we use here.
Excellent answer there, Kelsi. Sammy, what about you? A go-to strategy for making global virtual training feel personal and meaningful?
Honestly, just engaging in the chat. I found we have had some amazing cohorts who are very, very active in those conversations and have been sharing their own experiences, kind of like what we discussed earlier, and kind of how they're implementing the open science practices and principles into their own research. And kind of getting to engage in those conversations makes, the big idea of open science feel a lot more like intimate and collaborative and attainable. So those have been really fun. And just being able to, call on people and bring in questions. And it's been a really important part, I think, for making the trainings feel more personal and meaningful.
Absolutely, and we could not do that without your support on that, Sammy. I will even go so far as saying I mentioned earlier, I've seen over 1,000, 2,000 individuals across all of these trainings that we've done. And I recognize some of the names that are in our attendee chat right now particularly because they were individuals who are very active in the chat as well. And so I do tend to recognize these things. If you're having a fantastic chat with another individual, I'll see both those names and I'll say, oh, that is phenomenal. Make sure to find them on LinkedIn and thank them for their participation in the course. And of course, if they have any questions left over, to follow up. That said, my go-to strategy, since I'm often not as active in the chat when I'm delivering live instruction, I will make sure that I use the 10-minute tea breaks that we do to answer any questions in the Q&A. So making sure that no question goes unanswered is a big thing for me. And then also, when I'm teaching, you'll notice that I tend to lean heavily on both demonstration as well as anecdotes. Demonstration, because I use demonstration because it is much more engaging. Like watching somebody do a chalk talk, I think is always more fun than just watching somebody read off slides. And for the times that you do have to read off slides, I think making it relatable by drawing in some type of personal anecdote. And so if you're able to relate to either the individual who is teaching, or if you're able to relate to the content that's being taught, you are more likely to learn it, you're more likely to engage or pay attention with it, and therefore it's more likely to kind of sit and linger around in your brain as something that you've picked up or learned. So those are the two things that I always make sure that I try and bring to the table, are going to be demonstrations and anecdotes. But in the interest of time here, let's jump down to what will be our very final question. And that is our pep talk. So I'm curious, we'll start with Sammy and then we'll go to Kelsi. Sammy, for someone on the fence about getting started with open science, what is just your one sentence? And of course, no points will be deducted if you mention 2, 3, or 4 sentences. I think I had a whole story the last time we asked for one sentence, so anything goes.
So I really like this question. Honestly, my one sentence pep talk, a little subtle plug, but I would say definitely do an open science training. That was where the kind of the door was open for me and kind of answered a lot of my questions that I had around it and kind of started my interest in open science. So definitely like we're here to help. And if you have any questions, I'm sure I had the same ones. So I think that's always a really great place to start, is kind of just jumping on into the community through a training.
Awesome. And Kelsi, what about you? What is your one sentence pep talk?
I would say one sentence. Okay.
It can be more. It can be more. So it
Okay.
doesn't, don't feel the pressure of one sentence. This is not like a 200-word abstract where you're
Right.
fighting for
Very hard
space.
limit. Um, I would say the moment you start to share your work and your data, you're already a part of the community, and the community is so supportive. So basically, you're coming into this community of open science, and everyone wants to help you and contribute to the bigger goal. And whether you start small or you start big, so you're already joining a community that's going to be super supportive and help you contribute and help you share and get acknowledgement and make sure everything's reproducible.
Absolutely. I think that's very important to highlight of there are communities that you'll join that you'll see where on the surface level they feel welcoming, but as I have been doing this for a couple of years now, I've joined many different open science communities, and I've found them all to not just be superficially welcoming, but also welcoming on a very deep and meaningful level, where no question is a dumb question, and every question receives the same amount of respect and thoroughness and thoughtfulness in its answer or response. And we have to kind of do away with some of that, oh, I'm scared to ask a question because I don't want to look silly or inferior to someone else. And I think that's kind of, it's been part of the culture of academia, whereas like asking questions can be both be seen as like a good thing or also a weakness depending on whom you're interacting with. Whereas open science, I've never met an individual who said that my question was silly or I don't know what's going on, things like that. So it is a very warm and welcoming community that you should also participate in. And so that is all the time that we have for today. I want to thank everyone for joining us. And if I could get also a huge round of applause for our teaching assistants, both Kelsi and Sammy. You all have been doing a very wonderful job with the training so far, and this has been a particularly fun session where the audience, our attendees, get to know you, get to know us, and how we approach these trainings a little bit better. Thank you all for your time today, and I hope to see you around either at a future training or in our direct messages on LinkedIn or in our email if you have any open science related questions. And do make sure that you spread the word about these open science trainings, because we want to make sure that this training reaches as many people as possible. Thank you all again for your time today, and I hope to see you all real soon. Have a good one.